Okay, so I think we can start, please, Viso. Thank you.
Okay, great. Hi, guys. I'm Viso, and today I'm going to talk to you about the NuActor system. So new as in NuNet, and new as in new because it's brand new and state of the art. Okay, so as the subtitle says, we're going to talk about actors, capabilities, UCAN, and security at depth. So this is how we plan to secure our network. So please pay attention and ask questions. All right, so first of all, let's talk a little bit about actors, right? Here, actors there, everything about actors. Kabir has been raving about actors for so long and nobody understood him. So, okay, let's demystify them a little bit, all right? So at a very basic level, when it comes down to programming actors, an actor is just an asynchronous thread of control. It's something that's running in parallel asynchronously, maybe starts and stops, maybe on a different machine, maybe on a different continent, like everything. So all you have about it is a mailbox, and you can send messages to the mailbox. So the actor system, is responsible for delivering to the actor however it can. Okay, but it's completely synchronous, right? You don't block on the send. That's it. You send it, and that's it. So as I said, it can be locally remote, and what we need is the handle. And why the rave about actors? Well, they're very natural in distributed systems, right? So distributed systems running in some cloud. So you have a bunch of hosts, multiple processes running in the host, and then multiple actors running within its process. It composes very nicely. So that's why it's all about actors. But we are not building a distributed system. We're building a decentralized system. The distinction is subtle. Okay, basically what changes is control and agency. So different actors in the system may have a different controlling entity, and and they may apply agents on its behalf, and that entity might even be malicious. Okay, the system is open. Actors and entity who control them come and go. And if you haven't read that chapter from Kabir's thesis on open-ended computing, I suggest that you do. But when we're building decentralized systems, basically we have security problems, right? All these entities that are in the network are mutually distrustful of each other, so that they can only trust the protocol, nothing else. Okay, for all it matters, that kid that you're getting the message from, which is a teenager, in Ukraine having fun because he thought you're Russian. Okay, so basically, as long as protocol is followed, yes, you have some basic framework with which to interact with your actors, but there's let's be real here. There's no perimeter, so there's no perimeter defense here. The system is open. The messages are coming from the internet, and as we say about the internet, what can possibly go wrong? Okay, so I have a question for you here. How do you think we can secure actor interactions in decentralized network? Okay, I pause here, and I would like to hear some questions or some ideas. Silence. Okay, well, ponder it for what
you can also ask for a panic attack kind of.
Yeah. So, yeah, guys. So please, let's just ponder it for a minute. It's a very hard problem.
Authenticating messages basically is one of the ways to know.
Yep. That's exactly what we're going to do. That's exactly what we're going to do. Security in depth. So since we have no perimeter, we have to safeguard every public behavior, every behavior on the system that basically, comes from wherever in the internet. Okay. So we don't trust the perimeter. There's no perimeter. We established that, right? So every message, okay, we need to be able to authenticate, but we can't do coarse-grained authentication. Say, oh, you got an authentication token for someone because you signed in, in Google, and you're going to be able to invoke my private, DMS actor stop behavior and stop my actor. No, it doesn't work that way. So we need very fine-grained capabilities that basically specify exactly what action you're allowed to do, nothing more, nothing less. Okay, so how we do that? We're going to use public key cryptography at 25.519 keys. If you ask me why and not SecP, 256 keys, sorry, I trust the IDF more than NIST. Okay, well, obviously, 25.519, we know it's like conventional cryptography. It may be susceptible to quantum computer attacks. Well, if we get large enough quantum computers. We're not there yet. We have at least 5 to 10 years. So I know that people already started using PQC in the context of web servers, for example, but we don't need to because we don't care about forward secrecy. The reason they do that and they double encrypt effectively is because, they care about forward secrecy. So when quantum computers become a reality, yeah, by then we'll be deploying PQC keys. So there is stuff for that already. So basically that's it. As secure as it gets. You can't do better. Don't make no mistake. So any comments?
Can you explain a bit more? Why don't we need perfect forward secrecy?
Oh, because the messages are already encrypted in transit by the P2P connections, and we don't encrypt the messages. We just sign them. Once we don't need to double encrypt. If you want to encrypt the payload of a message, the envelope has to be unencrypted so you can forward. If you want to encrypt the payload of a message separately, that's up to you. So the system doesn't. So it just takes a blob of bytes. If you want to encrypt it, that's for you. If you want forward secrecy or perfect forward secrecy hit, please encrypt it, use PQC, double encryption, whatever you want to do.
Okay, thank
But
you.
the envelope needs to be accessible, okay?
Okay.
All right. So how do we anchor all this in the centralized system? So there is a natural solution. The DID, decentralized identifiers. So basically what they are, really they're means to get public keys belonging to certain entities, right? It's a very lightweight and open identification of internet. Basically, it can be completely anonymous. It's just a key. Could be pseudonymous, like a blockchain key, which has some funds in it. Okay, or it can be fully know your customer, like it can be anything you like. So, but basically this is what they look like. It's DID colon method column specific identifier. And underneath there is an example from a DID key, which came from a test. Sorry, I just picked it up from its randomly generated key. So basically what all you need is a method to get the public key from the DID. And for keys, it's embedded. The identifier is a public key encoded. Okay, and methods are well known and it's escudayana. So if you're gonna read a little bit about the specification, I recommend it. It's good reading. You don't have to read all the details, but getting an idea about what this is about, it's a good specification. Questions? I thought we were gonna start. Finally a question. Go on.
Yeah, can you elaborate more on DID methods?
Yes, basically the method, it's a URI component. Basically, it's a short symbol that specifies how, given the method-specific identifier, to basically get the key. So you might have to hit a URL on the web, for example. Okay, or you might do what we do with the key method, which basically encodes the public key there, and you don't have to look up anything on the net.
My question, still when I see the idea, I think Docker in Docker shit. Who provides me the key?
I'm gonna answer this question because it's very good. We're gonna see it, like everywhere around. We're gonna talk about it extensively, how we're gonna build those keys. But basically, think you generate your own key, and you ask some entity that can give you capabilities to give you a delegation token for your key. That's how it works. So you're talking about trustless. So a comment there about trustless. Please speak up when you have questions. Or someone, please read them to me. Zanaina, if you could do that. Yeah. So what was your question?
Yeah. Actually, I had one thought coming up. Like, what is the difference between trustless and zero trust? So, I think.
Okay. Trustless. Yeah, trustless means anyone can join and start doing stuff without needing anyone to vet him. Zero trust, it means we trust no one and we only execute actions that are vetted by something we trust. Does this make the distinction clear?
Yeah, so like trustless as in
As in a blockchain,
decentralized
say in Bitcoin, right? It's completely trustless. You don't need permission to do anything in the network. Here, you need to get permission by someone who controls the entity you are hitting, or someone who is trusted for the certain capabilities by the entity who controls the resource you are hitting. So it's a subtle distinction, but it's real. It's a good question.
Thanks, Will. Thanks.
So, Visa, if I can try to formulate this distinction, at least the way I was thinking, that basically zero trust, that I do not trust anybody by default. And basically that's default mode. However, I can establish trust, and I have tools in order to figure out whom I trust in the system. That's pretty much it.
Exactly. And on top of what you just said, is transitive. If you trust someone to hit some endpoint with some capability in your machines, then that someone is also allowed to delegate this trust, so that basically he can have another agent acting on his behalf. So basically, it's
I
transitive.
believe this is like addition of user control authentication networks on top of zero trust
Yes,
concept.
the next slide. The next slide. Exactly, that's what it is. Okay, so well, the IDs are the anchors, the basics. How do we do it? Well, there is a great project that's called UCAN, User Controlled Authorization Networks. It was started by people at Protocol Labs, Blue Sky, some other Web3 companies. So it's a very nice scheme for, I think of it as a scheme, right? It's a mechanism. So basically creating an open lightweight certificate infrastructure based on the IDs. So open by design, each participant is free to trust anchor in whatever DID they like. So you don't sit with the trusted root certificates like in the PKI, and that's all your browser trusts, right? But it's a different system. They have different requirements, okay? But we know that that system with PKI is mostly broken. Okay, this is a much more lightweight, and basically it's much more directed, much more like a much smarter scheme for handling authorization. So basically, we have a hierarchical namespace of capabilities. We start with slash. It's like Unix paths in a sense, slash something, something else. And basically, capabilities allow you to delegate actions or make invocation based on these capabilities. It's completely frictionless. And it should be noted that capabilities, especially as the chain grows longer, are attenuated. So they're short-lived, and basically they can only narrow the capability you're allowed to invoke. So if you have capability for /TMP, you can only narrow it to /TMP something instead of widening to or going parallel to /something else. Okay. So there's a UCAN working group. They're standardizing envelope formats. This work is decisively not done. They don't have delegations, and basically without delegation we can make our system work because the actor IDs differ from the ID of the node, because we allow sub-actors inside other actors. So we need to be able to delegate with specific subject and specific audience. I'm going to talk about this a little later, but basically we need to tie the actor IDs to the DID and inside the token. Okay, but when there is a standard envelope for delegation, we're going to accept those envelopes so that our users can bring their own delegation, basically. So here's a link to the spec. It's a very interesting document because it has a lot of motivation, background, etc., etc. So I think it's insightful, and I strongly recommend to read it. All right, questions?
Are you going to speak about chains? Sorry if I missed already. Chains of certificates and how exactly I can trust, because I mean, how
Yes.
let's say this chain, and when do I need to reach and
I'm
check
gonna
the
talk about this later in the talk extensively on how.
All right. So I'm waiting. Thanks.
Okay. All right. So okay, from theory to practice. So I'm gonna cover the last 10 days or so. Like the NuActor system was implemented. It's already in main. There are some details missing about the broadcast. I have an open draft PR. It will be done, like by the end of this week. So basically, the design is such that it has to be effortlessly to program securely. You have to really go out of your way to introduce security bugs. That's the idea. Okay, because a lot of systems promise security, and then it's impossible to program with them. Take OpenSSL. Okay, you need to wrap, in some ridiculous layers of libraries in order to make it usable. Okay, here we just do absolutely effortless. So basically all you have to do is remember this line at the bottom. It says defer message discard to basically deterministically release the tokens of the interaction that come, with this message. If you don't, if you forget that, the consequences can be none, as in the tokens will be garbage collected when they expire, or they could be catastrophic because a spammer found, an open avenue into the system, and it's going to fill you with self-signed crap certificates that expire in 2262, and you're going to run out of memory. Please don't forget that. That's the only effort that's required. Okay. So basically, how does it work? In order to send, the programmer constructs a message and give it called actor send, and the kernel fill in the capability details for you. In order to receive, You put a behavior handler, which is basically the name of the behavior, which matches the capability, and basically just a function that takes an envelope. That's all it is. Okay, during dispatch, the kernel will do several checks. So I'm going to talk about dispatch a little later, but rest assured that the capabilities are verified and the call will go to the void the message will go to the void if it doesn't have the requisite capabilities. All right, questions so far?
Well,
Okay.
my question would be a little bit not into the point probably, but can we actually put this sort of defer message into somewhere that we can test that it's implemented, like in lint or whatever?
I have a test for discarding. Okay, it's implemented.
Okay.
All right. So, okay. That's the actor packets. Let's talk about the most important thing, when it comes to security. This is a security context. Every actor has an object that's called the security context, which is anchored in a capability context, which is process-wide. So the security context is actor specific. It has the private key for the actor to send messages. The capability context is process-wide, and it tracks, not process-wide. It's an object, but we use it process-wide in DMS because, it's dependency injection. So anyway, the capability context, which handles all the active tokens for interactions, and itself, it sits on a trust context, which has the private key for your DID. That's the nose DID. So in DMS, it's equal to the peer ID, and different encoding, but it's the same key. And obviously, it's also the root actor's key, so that it's predictable, and we can reach it from outside as long as we know the peer ID without having to guess. Okay, so let's put this a little bit like a pyramid, right? At the bottom there is the DMS process. This is the enclosure for all your compute state. In there is a trust context, and on top there is a capability context, and then there are multiple actor security contexts. Okay, is that clear?
So there can be different security contexts for child actors?
Yeah, of course. You can share it. The root should never share it, should give different security actors for every actor they create. But inside another actor, you can create a sub-actor that has the same security context and has the same, ID. All you need to do is use a different inbox address, and this happens automatically because we randomize those except for the root.
So is it shared or?
No, it's served by sub-actors. So if you want to make threads, with mini actors that live inside your actor, okay, and basically they identify as you because there are actually multiple threads of control inside your actors, you can do that and serve the security context. It's not the default. The default is for actors at least for actors that get created from the root, is to make a new security context, can generate, a new key pair for the actor that's being created. They're ephemeral. Only the root is persistent.
All right.
And yeah, sorry, David, if you have anything further.
No, go.
Yes, I wanted to ask the root. Is it my imagination is true that the root is something, we have multiple roots and each node will have a root?
Each node will have its own root, yes. And then how they relate to the DID of the owner, it's the root trust anchor. So its root for its DMS, it's going to have some root trust anchor, the owner, which is the owner's DID, and that's a DID that doesn't live inside the DMS. It's going to live, inside the key store. That's why we're building the tooling.
And I think
so that's for Zoao.
Yeah, yep. That's important aspect to mention for those who are actor system in the other world. They have a single root, and we don't have single root.
Absolutely, we have multiple roots. It's the system is designed to be flexible, so you can invoke public behavior without requiring to give anyone root other than yourself. So that's how you get the community can trust us, because we can't get root on their machines unless they give it to us in order to help them debug something, for example. But we can't. The software doesn't ship with anything. The security is there. You initialize your DMS, you put your own DID in there. By the way, this is why it would be really, really nice to have that Ledger wallet integration so that the personal DIDs can be generated and live inside the Ledger app. Maybe we should write one if it doesn't exist. Kabir, what do you think?
Well, I think that would be perfect, but not for RC1 for sure. But yeah, let's look at it. I would say, what about trying to use the current Ledger apps that are just signing? Let's say,
it should be doable. That's it. As long as we can get the public key out and give it a blob and give us back a signature, then we can use it. That's it.
Yeah,
We just have to make sure we
afterwards
support their
we
case.
can we can see
Yeah, yeah.
whether we can write an app.
So if we find apps that do that, we have to make sure that we support the kind of keys they have. There may be SecP256 keys, for example. We'll just need to add support for, you know, like parsing for the multi-codec and the encoding of the key. It's very easy, you know, once we find something.
So I wonder if Safi is around. But yeah, please take that into account. I see Tanya is listening, so yeah.
Yeah, so actually here is a question. So I was just researching about different DIDs. So there are some those support different signatures. So we are seeing at 25519 and then SecP as well. So
If we have a 2519, then we're perfect. But yes, we can easily add support for SecP keys, you know, to accept SecP key DIDs. You know, it's a minor modification.
So for us, the requirement is at 25519.
Well, either 25519 would be great, perfect. That works. If instead we find SecP, that's acceptable. Very small code changes. Remember, all we need is a way to get the public key out. Of course, we'll provide one through the Ledger app, and a way to give it a blob, you know, like a small piece of binary data, or the hash of it, and basically sign it. That's all we need.
Okay, great.
Okay, so actor ID and DID. So I mentioned already, you know, there's a difference between the actor ID and the DID, right? These are the two pieces of identification that we need to uniquely identify the actor in the network. It's DID, that's the DMS DID, where it lives, and it's ID, which is public key, which in the case of the root actor, the node, it's the same as, you know, like the DID key in effect. Okay, so all actors are created afterwards, unless we specify otherwise. They have ephemeral private keys, which doesn't generate new keys. Okay, because when the process goes down, these actors are going to go down too, and when they come back, we don't want people trying to reach them. You know, the message will go to the void. They have to engage through the supervisor, restart logic, you know, like, and all these things that are there. Okay. All right, so let's look at some code. Okay, here is the handle. That's how we communicate with actors. All we need is their handle. Okay, so it has a ID, a DID, and an address for outring. The host ID is basically the peer ID of the DMS where they live. You know how to find it in the network. And the inbox address is something we use internally for dispatching. It should be randomized. It shouldn't be the actor ID. It should be randomized. Exception, the root actor. Mobin, hope you're paying attention. For the root actor, we shouldn't randomize the inbox address. Let's just call it root, because, you know, the tool needs to be able to needs to know it, you know, just by knowing the PID or or the DID. Okay, so here's the actor interface. There's some more stuff, you know, like not particularly important for the sake of the discussion. So basically, there is a way to add behaviors. Basically what it is, the string, the continuation, which is basically just a function that takes a message. By default, the capability is going to match the behavior, but you can, you know, add a bunch of options. You can add more capabilities where any of them is satisfied. So this is useful for doing compatibility things. For example, you can expire it. You can have it one shot, you know, so they don't receive a single message and it disappears, things like that. Okay, and then there is receive, which basically tells the actor, hey, take this message. Okay, send, hey, Mr. Actor, send this message. And there is invoke, which basically takes a message and expects a reply. Okay, so it gives you back a channel, and you can wait on this channel for the reply, which is another message. And then there is broadcast support. This is brand new. I'm working on it still. You can publish and subscribe. Okay, and this is what the messages look like. This is the envelope, right? This is goes back to Umer's question earlier. You can't encrypt this because you need to be able, you know, to see the envelope headers, but the message itself is bytes. If you want, you can encrypt it. Okay, so there is a to, which is the destination, the handle, the behavior to invoke, the from, which is the origin of the message, and there's always a nonce, of course. And there is some options. I'm going to talk about it later. And here, the bottom two are perhaps the most important after the message. Capability is basically a binary representation of a capability tree. So it's just a JSON object, really. Okay, that is the tokens that you are passing to the other process in order to support the interaction. Okay, and then there is a signature. Everything above the signature is signed. Okay, and it must match, like the ID of the handle in 2. Okay, so 2.id, it has to be able to verify the signature. Now the options are referred to, expire. Every message has an expiry. We don't send messages without expiry. Okay, we don't want your messages to live forever, right? If you doesn't get to its destination within 30 seconds, that's discarded, so forwarding. Okay, reply to, it's important, which is the behavior to reply to if you want to initiate an interaction that goes back and forth. And if you're broadcasting, it's the topic. So how does it all work here? How you send the message? So basically, you construct the message, and then you ask your actor to send it. Okay, that's it. And this is how you receive it. You can just add the behavior. Don't forget message discard, and do whatever it is you do. And this is what's happening underneath in a somewhat simplified, version, right? So the message hits the actor. The actor asks the security context to provide the necessary credentials to capability tokens to the invocation, and sends it to the network. The network sends it to the network substrate, which is the network object sends it to the network substrate through libp2p. It hits another network object. Then basically, it sees the register handler for the message type, and it can forward to the dispatch of the destination actor. Okay, that's through the inbox address. Okay, so then the dispatch first calls, first verifies the message. I'm going to talk a little bit more about the dispatch, and then it calls require the security context to check the capabilities. Okay, so nothing goes in without capabilities. That's it. And once everything is satisfied, then and only then we spawn a routine to handle the message. So it's massively concurrent.
So we're talking about two actors messaging each other, right? Like, can you?
Yeah. That's a simple send. That's a simple send.
Right. So can you tell us how provide and verify require work?
Yes. That's in the following slides, of course.
So sure. Okay.
But anything else? Any comment you would like to make?
Just one question about invoke. About the
it's coming
behavior.
here. We're going to talk about invoke right after. Okay. All right. Okay. So basically,
real quick, can you go back?
Yes.
So the assumption here, let's assume that the origin actor is actor A and the receiver is actor B. The assumption here is that the tokens that origin A has have been provided by B.
By provide.
But how can an actor provide capabilities of another?
We're going to talk about this. That's the provider because you have anchors. You have your capability tokens that delegate you the ability to do certain invocations. You can also provide self-signed. So if the other side directly trusts you, it will accept your message. But we also have anchors. That's what we distribute. To say, hey, that's why we're discussing that, the DMSs need to accept a token from us that basically says, I allow, anyone who is anchored, basically on me as a delegation for the public capability. So we'll talk about this more. So basically you provide context. This is what the dance with grant and add roots were doing.
All right.
Yes. All right. Okay. So message dispatch.
Sorry, I have a question before. Sorry about that. I know people
go ahead.
with questions. It's just
no, I love it. I love it. Compared to the previous presentation where I had the silence and I hated it.
It's good then. So just before we go to more in-depth details about how this infrastructure of security works, I would like to ask before that, in a general context, that's why I'm bringing this question before everything else, how can we, how can I say this, verify?
Initialize things, right?
It's actually not initialize, but verify that the solution is, how is the security solution verifiable in the sense of?
I see. Well,
that it's doing exactly what it's doing, yes.
All right, so you have my basic guarantee that the code actually works, because I wrote it very, very carefully and he's been reviewed, but we're also undergoing security review by Serdar in depth. He already has done a first pass and it looked good. So now he starts with doing, a deep security review and the verification. Okay, but the code is good, we might have some subtle bugs. I'm not saying no, so that's why I asked Serdar to secure. And like if it would make you feel better to ask someone external to audit, we could do that. But in my opinion, in my experience, it's a fucking waste of money.
Yeah, cool.
Better to open source it and let the open source community, all bugs are shallow, right?
Sure. Yeah, sure.
Yeah.
I was just thinking about less of in terms of auditing and more in terms of verifying the
verifiability
properties, the composition of properties, of security properties actually
yes, you're asking for formal verification.
Doesn't open up something like, I don't know, the confused deputy problem that we implementing this kind of stuff, kind of problems.
No, this is a good question. Formal verification is possible. It is possible, but we're going to need to spend money and time on it to do it. So right now we settle with auditing the code, right? But once it's out, and if it becomes standard, because it is state of the art. Make no mistake, this is state of the art stuff. Okay, and if it becomes standard and others are using it, then I'm sure some PhD student is going to step up and going to formally verify it, and we'll get a formal verification for free, right?
Good.
Right. No, I would love to have it, but right now we don't have time. We don't have. There's no need to spend, like $500, $1,000, on getting it verified, because we can just audit the code. We have experienced security engineers, and they can read the code carefully and analyze. And also, we have an issue to write adversarial test. Hamza is asked for that. It's considered a priority issue, to write adversarial tests for verification. So I'm taking this very seriously. That was a very good question.
Sure. Thank you.
All right. Now let's talk a little bit about message dispatch. So it's massively multi-threaded at the end. Multiple behaviors are running on the same time, in concurrency. But of course, you can't start spawning Go routines with every incoming message, because you could be spammed to death, before you know it, right? So there is a pre-allocated pool, of threads that are sitting in the front end. One will do. For the root actor, we can consider having more. Okay, and basically the sole job of this thread is to basically take the incoming message from the queue and verify the signature. If the signature verification fails, trust. Okay, once it has been verified, it enters a second queue where a single thread, this is the main dispatch thread, is running, and there we check the capabilities. Okay, we could have multiple dispatch threads, but it's a log. We don't gain anything by more, because then the logging becomes complicated. Now it's a simple log. Okay, and once it is verified, the capabilities, then and only then we spawn a Go routine, a new thread, to process the message by invoking the behavior. Okay. So any questions about the dispatch before we go into invocations? Okay, let's talk about invocations. So we said we have an invoke primitive, right? So the reason for this primitive is that, pretty much all the naive implementations of factory systems, what you do is you say, oh, I send a message, and then there's no way to receive a reply. You have to write, another handler to receive the reply, and you end up with what we call the callback shell. Okay, we don't do that. You're smarter than that. The library allows you to call invoke, which is going to give you a channel, and you can wait on this channel with timeout in the message expiry, and automatically it will create a reply to behavior, register a one-shot behavior, handler, which basically picks up the message and puts it into the channel. That's all there is to it. Okay, and this is how we do it, right? So at the call side, basically we make a message. We say, notice this underscores that I have. This is errors that you should check. Please don't do underscores on the errors. Okay, but it wouldn't fit on screen then, so I can just put it like that. Okay, we construct a message, you invoke, you get the channel, you get the reply. Don't forget to discard the reply, please. So that's note for the reviewers. On the other side, you have the behavior, and here what the behavior does. It takes the message, doesn't forget to discard. It makes a reply message. Note that where behavior it invokes, it comes from the message, is the reply to. Okay, and we also set an expiry, which is the same expiry as what can mean, so that basically you're not going to end up wearing clown shoes if something timeouts in the middle. Everything will time out and stop processing. Okay, and you just call send. That's it. Well, underneath it's a little more complicated, right? Right. I'll give you a minute to look at the diagram and try to grok it. So the green lines are the thread of control, at the call side. The orange lines is the flow of the messages inside the system, and the black lines, are synchronous invocation in the security context, dispatch, etc. Okay, So let's start from the beginning. Is my pointer visible?
Yes.
It is.
Yes,
Okay, so we start here. Invoke, okay? Invoke gives us back a channel, and we block here. We wait for the response. So inside provide, if provide fails, it's going to error without actually sending anything. Forwards to the network sends it to the substrate to the other network. From the network to the dispatch, require the behavior to invoke. Okay, go behavior, send reply, provide the behavior to reply into the network through the subset into the network back into dispatch, require behavior to reply, then go reply, which basically signals the channel, get the reply, and we unblock. Okay, questions?
Can you go once more over the message flow?
Yes. Okay, we start here. No. Okay, so we start here at invoke, right? So you hit the actor, set the actor invoke, and you get back, basically, it checks the provide. If the provide errors, it returns you an error. Otherwise, it gives you back a channel, and you block on the channel. That's your outside thread of control, right? Inside, as we said, massive multi-threading, it goes to the network through the substrate to the other network, and from the other network into the other dispatch. Okay, so far?
Where do you keep the channel? Do you have like a data store somewhere?
No, nothing. It's there's the one-shot behavior where I registered to handle. This is the go reply to, basically. That's here's a reference in the closure of the channel. There's no database, nothing. It's a closure.
Will it be possible for you to add numbers in this diagram, like 1, 2, 3, something, so we can see, okay, which flow it's going?
Okay. Yeah. Well, I can do that. Well, when I use a diagram for, like the documentation, which is coming, I'm going to write a README, about all this. Then I will add numbers there. Okay.
I think I will suggest we can talk later about sequence diagrams, because I think we will need to have sequence diagrams for that.
Yeah, here a sequence diagram might be good. I just want, I like Excalidraw. I got pumped about Excalidraw. Look at these hand-drawn diagrams I can make. And I loved it, so I did it this way.
Yeah.
But yes, a sequence diagram could help here. So really does like a flat on top view of a sequence diagram. All right, and a little bit about broadcast. This is something. Doug, question.
Sorry, just one question. Is there an expiration while we're blocking on the channel, or
yes, of course. Here, like in the code, you shouldn't just wait on the channel. You should do select channel envelope and use the message expiration. You get the expiration.
So it's
the message has an expiry an expiry time method that gives you like a time, and you can do time after, or you can create a timer and wait on the timer.
Okay, and the second question, from the struct or from the message signature of the invoke there is behavior option. Is that behavior option for the destination actor?
Behavior option? No, this is for the behavior that you want invoked. You can change certain parameters. You can make the basically expire. By default, it expires with a message expiry. We're not going to leak a behavior, but you can change certain things in the parameters. So just look at the code about what behavior options we have.
No, my question is, invoke would be basically the same as send, right?
Send and wait for reply. So yes, if you would do it in a naive actor system, you would have to do send, register behavior yourself, pick up the reply, and continue in a callback effectively. Yeah.
Wait. My question is, why is there the behavior configuration here on invoke, but also send? So are we configuring the behavior
so that
on the destination actor?
Wait. It has a default behavior on what it does, but if you want to handle it, the reply to yourself without registration of the 1-2. So, okay, let's see. Actually, I should probably remove the behavior options from invoke. We don't really need them. Yeah. The only thing that makes sense is to basically set an expiry, but this is automatically set. I will remove it from the signature. Okay.
All right. Okay. That's the one question.
Yeah. Sorry.
Kind of look at it more closely before deciding, but yeah, it's a good question.
Yeah. I think you're right. I don't think we need any behavior options for the invocation. I just future-proof myself by putting there, in the signature.
All right. Okay.
Yeah. Okay, dispatch, invocations. All right, and a little bit about broadcast. So PubSub with Gossip Sub, the interface is very simplified. You don't have to do anything at the PubSub layer. All you have to do is tell, what was that? Sorry. Tell your actor to subscribe, and then you use normal behaviors. It's just to add behavior, like one option that you need to use in order to make it broadcast accessible is basically specify the topic, and then when a message is coming in, credential capabilities are going to be checked, and if and only if it's whoever sent the message is allowed to broadcast, only then we would dispatch it. And on top of that, I added a message validator, so we can take advantage of what Gossip Sub has to offer when it comes, to validation, and then we can start thinking about implementing scoring in there, and generally keeping our network secure from, like network level attacks, like trying to DOS us or things like that. Okay, so far so good, right? Now it's time to talk about the capabilities themselves.
I have a question in the PubSub. So where exactly are we storing the message that is to be published?
We don't store it, you just send it. Basically just call, you just send it. That's it. You make a message which has an empty destination handle and uses the message option with message topic, and you call send and it just sends it.
So
broadcast.
What if it's not broadcast? So is it
It
working
knows
like
if it's not,
UDP?
if it is broadcast, it's going to use a different path on the capability tokens, because there are some slight differences, like on the invocation. It's not an invoke token, it's a broadcast token. But yes, the system knows when you're sending PubSub, because you tell it, I'm sending this to, I'm giving you no destination, but instead I'm giving you a topic.
Is
Actually,
that
I think I have a publish. Yeah, I think I have a publish method, right? You call publish. I guess we could do it with send, but for some reason I thought it would be a good idea to differentiate it. So I have, a publish interface method.
Sorry to interrupt you. We can. I'm not sure if this is possible with publish and send, because send is using direct.
But send can see, that you're sending a broadcast message. But I used a different endpoint. I used publish because it's simpler to write it this way. The logic is simplified because publish.
I would recommend we keep publish, because it also adds this,
Okay,
semantic
I
of
will keep it. I will keep it.
publishing.
It's explicit. Okay,
Yeah,
it's
exactly.
explicit and there are checks and you can't make mistakes. Yeah, I guess that's why I added it on the first place. Yes.
Yeah.
Thank you, Bobin.
Does the publish subscribe behaviors, like, do they implement the same stuff as send and receive, or do they?
So basically, the behavior has the same signature. It takes a message, but in order to be reachable through PubSub, it has to specify the behavior option that specifies the topic, and the topic on which the message came from must match what you declared. Otherwise, the message is going to be dropped.
And there is no capabilities to talk about.
There are capabilities everywhere. So basically, you can't. Your spam messages won't be accepted unless you have the requisite capability tokens.
In this case, you should have a capability to call the topic.
To broadcast, not
broadcast. Okay.
Yeah, there's a separate envelope class basically that I'm making. You can, like the working group don't even have this on the radar. Maybe I should open an issue to them and show them what we did here. But basically, there is a broadcast capability that is delegatable if there is a topic, an audience set, to your provider. So we're going to talk about this.
I have a question. I didn't understand it, like your answer before. So, if I'm being naive or wrong, please let me know. But if there is a topic and that is intended to be for multiple recipients, right? And then on the other side, you have to subscribe to a topic, right?
Yes, you have to subscribe.
You have to store somewhere, like which are the recipients, or is it the part of
No,
message
this is not
or
how PubSub works. PubSub doesn't know the recipients. It sends it to the topic, and there is, a pretty advanced algorithm, I would say, for sending the messages around. And there are security mechanisms, inside Gossip Sub was designed for, blockchain. So you put a lot of effort into making it secure, or secureable at the very least. So I'm going to take a look on what we do, on PubSub, and I'm going to, harden it a little bit.
Okay.
So for starters, I added the validator, which was missing previously.
Okay.
I want to let you know, considering the importance of these aspects that we are
13 more minutes, right? Okay. Yes, sorry.
No, actually, it's that what I'm saying. I want to say is that I think it's better to cancel the daily for today. We please set the any blockers or status asynchronously on Slack so you can
Wait,
move
13
on.
more minutes. Let me count 1, 2, 3. No, we can do it in 13 minutes, I think. If we overflow by 5 minutes, it's okay. Because I do want to do a daily today. I want to talk with Sardar, you know, like with you present as well, and UMR once he's there, because we need to decide the ceremony.
Okay. So I will let this up to you.
Okay. All right. We'll see. If we overflow too much, we can. All right.
Yeah,
Capabilities.
Please explain like don't forget to explain the provide and require and how we're doing anchors.
Looks good.
Well, I would like to
go
just
ahead,
jump in regarding the topics. I think Umer's question, yes, makes sense in the sense that if we have publish and then topic will have to be determined by actor, actor has to know which topics it has to publish.
Absolutely.
So there will be
yes, absolutely. Absolutely. And no, you're talking about discovery here, the problem of discovery. But we can have a well-known topic where we can discover other topics. You know, that's fine.
Yeah,
that's easily solvable.
We'll have to have well, it's solvable, but we'll have to have some sort of logic to do this. An actor will have to know.
Sure. Well, you can add a public behavior reachable from broadcast on the topic discover, NuNet/discover, and then we can respond with what topics we know about. You know, like, and then we can make the system discover. I'll put it on my issue for, you know, like the endpoints that I want that we have to implement the public behaviors for the CLI. I will add support for this.
So the way I'm thinking about the difference, something that I believe the difference between publish and send is that gossip is basically a routing mechanism. Right?
It is, yes.
To find, and it kind of makes sense conceptually to separate routing mechanism from actual sending.
Yeah, I agree. We'll keep the publish method. I'm not gonna remove. I was just thinking, oh yeah, we can just send, but yes, publish should be separate. What was the question? I didn't catch it. Can you please speak up?
Whose question was that?
Someone typed something in the chat. I thought it was a question. Apparently not. Okay. Good. All right. Yeah, let's talk about the capabilities. So basically, hierarchical namespace. So, and basically, so we can do separation. Root is root. Okay. And basically, the names of the behaviors are the same as the capabilities. But, you know, like we do have the flexibility in the API to specify this joint set of capabilities so that the same behavior is reachable with multiple capabilities. You can do that for compatibility. For example, if you moved things on a different namespace and you want to refactor, you know, like, during a transition period, you can accept both, you know, like, and that's fine. Okay, so the capabilities can be delegated. That's the most important part of UCAN. That's the beauty of UCAN, is that if someone gives you a capability to do something, you can delegate, you know, like that capability to someone else, but it has to be attenuated. So the expiry cannot extend, and, you know, like the capability itself cannot widen. It can only narrow. So you can only add to the end of it. You can't go parallel, you know, or go up, all right? Okay, yeah, there are certain restrictions for, you know, like invocation, which is basically the send or the invoke. The subject and the audience must match the actor IDs of the origin and destination. That's why we need the delegate tokens. Okay, something about private networks, because I'm saying that, guys, we don't need private networks. It can be all public because just have different roots of trust, and that makes your network public, private in a sense. So if you happen to interconnect with
an answer to a different question, like how about if we want to restrict certain topics from certain actors, and then it's not possible with gossip sub? So
yeah, capabilities. You just send, you know, the capabilities. So basically, if someone, so in order to send to the public broadcast channel, okay, there needs to be some required anchor that allows to broadcast, and we can specify one when, you know, like a user. I'm going to talk about this later, about the ceremony and the process too. Basically, ask us, hey, hi, I'm interested in UNet. Can you give me a token, you know, like to invoke public behavior and broadcast, you know, to certain topics? Well, we know our customer.
But
not only for broadcast, that's for everything. That's for everything. And the beauty of all this is that it's not just us that we can do it. Anyone who is in control of their message, you know, can do these kind of things, and anyone who is trusted by the community can do this kind of things. So, but the starting position is that we are the creators of the system, and we're well-intentioned, and we don't give ourselves anything more than what we need. So that's how we start.
Yeah, but the question is from the subscription side. So we can't restrict actors from subscribing to topics.
No. You can't. You can't. But you can't do that anywhere.
That was the answer.
Yeah. Okay.
So,
if you want to restrict subscribing to topics, which goes against the nature of the system, but you can do that by enforcing a hello protocol that basically, and have your validator drop the messages unless the hello is satisfied. We can do that if we want, but I would prefer not to do it.
Yes. Yeah.
All right. So here's what a capability token looks like. Issuer is the DID who signs the message, the DMS DID, like a user's DID. Subject, okay, that's the DID, which is basically, well, subject means who gains the capability from this token, if it's delegated, for example. Okay, the audience is to whom it concerns. So, for example, when we give out a delegation in order to allow someone to invoke a reply, we limit the audience to our actor ID, which is ephemeral. Okay, and so basically only this guy, that actor ID, that got the capability, can invoke our actor ID, and this is all, tied into the chain, into the capability tokens. So what action we have, which can be, delegate, invoke, broadcast, soon revoke, we're going to have those two. The topics to which concerns, and the capabilities that it grants, and owns, which is random bytes, 96 bits for now, expiration in Unix Nano, we're good until 2262. And then by then the AIs will just make a new, a version thing that changes the semantics of the expire. And the most important is the chain, what it anchors on. Okay, and of course, cryptographic signature. Kabir, you have a hand up? Okay, probably not. All right, capability token exchange. So continuously, with every message you're sending, you're passing the capability tokens necessary to complete the interaction of that message. So they're, basically they're all ephemeral. They're created, on the fly. They're lightweight. They're very small. A capability token is 250 bytes with a signature, so it doesn't grow too much. And basically the expiration, well, I have the same here. I should say the same or less expiration as the message are bound to, but typically it should be the expiration of the message. Basically, think of them as lightweight ephemeral certificates that we generate all the time on the fly. Okay. So when the message comes into the dispatch, the first thing that it does after signature verification, when we're calling require, is to consume the capability tokens. Okay, there's a set of rules. I'm not going to go into too much detail, but basically they must be anchored appropriately. Okay, they must grant capabilities appropriate. The audience must match. Capabilities can only attenuate. Expiration, cryptographic signatures, and of course, if there's a chain, recursively verify all this. Okay, all right, we consume it, but we also need a mechanism to discard them. That's important. The deferred discard. So basically, there is logic, to get rid of and throw away, tokens that we no longer need as soon as, the deferred message discard is called. And basically that defends us from spam, because no matter how fast the other side is sending, through the LibDB network, we are faster at responding, because, there's a channel, back pressure, internal calls, so they're running faster than what's coming in. So basically, we don't have a spam attack surface, as long as we remember to defer message discard. Please don't forget this. Okay, that's the only effort you need to use the system message. Don't forget to discard. All right, any questions so far before we go into the anchors of trust? Okay, so an anchor of trust. Oh, yeah, go ahead.
Sorry, before you start, can we go slow on this? Explain more on anchors?
Yes. Okay. Yeah. I was going to go slower on anchors. Yeah. The consumed. This is it's simple stuff. Again, the stuff that we want to verify, and once they're done reading the code very carefully, here, and verify to see whether we have any subtle bugs and everything. Guys, feel free to review the code. Right? If you think you spot a bug, please speak up. All right. Anchors of trust. Right. What's an anchor of trust? It's a DID. That's all it is. We trust it to issue delegation tokens from capabilities to strangers who are going to call us over the internet. Okay, so a root anchor, that's something we absolutely trust. That's our owner's DID. basically. Like as long as you put this into the roots, then it has root capability. It can do like anything on you. Okay, a require anchor is a side chain in effect where we get delegation tokens. Okay, that says for this capability, well, basically, effectively, it says what the subject is that so that it ties to the token you get on top. But basically, it's a way we don't fully trust things that are coming from the anchor, the bottom of this required anchor, but we do trust as long as the capability isn't exceeded. So if someone gives us, like a delegation, an invocation token that is anchored on the subject of, like the required anchor token, okay, then we will accept it as valid as long as the capability is within the certain set, in the certain range. Okay. The third type, let me finish that, and we can discuss all three types of anchors. The third thing is the provide anchor, which is basically a token. And when we send out our invocations, we send with all the provide anchors we have, plus we self-sign, because we don't know what the other side trusts. So we send out our provide anchors. Basically, invocation tokens rooted, delegated from our provide anchors. So now questions.
No, I was only going to ask you to repeat the require anchor part.
Okay, so the require. Okay, yeah. So the required anchor, if you can see here, is that basically it's a side chain where the issuer is the subject of this side chain, and something we have specially installed by our administrator or someone we trust with the right capabilities, like into our capability context. So you see that basically, go back to the require, okay, subject, turn, blah, blah, blah. So basically with all these anchor checks, and this is what it looks like in practice, you have an invocation token where the origin actor ID maps the ID, the origin actor DID maps the DID from the security context, which comes from the trust context, so it's a DMS or some user. The destination actor ID maps its the ID, capabilities explicit, and then there is a chain, it sits on top of a delegation object, which is either anchored on something, like on a root, or on the required side chain. Okay, and this is how the various parts relate. So I'll give you a minute to study this diagram because it probably explains how require works.
The idea of a side chain is not clear to me. Can you explain, like, what do you mean by a side chain?
Yes, I will tell you exactly why. Because if we didn't have side chains, you would do vanilla UCAN. Then basically they would have to trust us with root. They would have to anchor on us and basically trust us with root, or we would have to give it a delegation for every, like pair of user, like DMS, and that's infeasible. Okay. We don't want to centralize anything. We want decentralization and easy use, like for trust. That's the idea of the side chain. So I designed the side chains because I realized that, oh shit, either we have to do, continuous, delegation from some central space, boom, doesn't scale, or they would have to trust us with root, boom, I wouldn't. So side chains.
So the require side chain, like, are these the only properties that are available in the token, the subject and the capability?
No, the required side chain is not in the token. It lives in the security context, like of the destination actor, and basically it's linked by the issuer to the subject. Okay, these are links. Okay, so you have basically what must match.
Okay, so where does the required side chain live?
In the destination, in your, you who is responding, like to some behaviors, have a set of require anchors that live inside my capability context.
They've been delegated to you?
Yes.
Yes,
They have been, no, you have added them explicitly, delegating, like to some subject that, like it's not you, some stranger on the internet.
You add them as delegates?
Add roots explicitly. You add them as required roots explicitly. Remember the grand dance?
Yes.
Okay. Yes. Yeah. So the administrator has to add them, and we can have like an endpoint. It can even be broadcast for distributing like new ones. But for now, let's keep it to the administrator. All right. Provide symmetric, right? Basically, two sets of tokens. One is for what you're invoking, and the other is for the reply to, if there is one. So for the invocation, we check our delegation tokens, what can satisfy basically this invocation on our provide anchors, and we send them out, and we also self-sign because we don't know, maybe the other side actually trusts us. Okay. And like then there is a set of delegations for the invocation of the reply. And this set of tokens basically fix the audience. Okay, that's the key there. And how do we grant capabilities? Why? Well, the capability context has an interface method to actually grant. We get the token list. We can just put it in JSON, and we can pass it around. We can email it. We can send them through the network, and so on. All right, I think we're going to be on time, like only 5 minutes late. Right, questions so far, because now we're going to be putting it all together, see the big picture, like an end, right? No, fine, folks. Okay, questions. All right, silence. For once, I welcome it. All right, so putting it all together, summary. Its DMS has its own root key. It anchors trust to another DID. It's basically the owner's key. It can be multiple. Okay, and it anchors incoming invocations. Like on additional sidechains, it will accept things that are rooted, like in sort of trust, obviously. But this requires sidechain, which allows us, to quickly delegate capabilities, if you like. Okay, and outgoing invocations are all put on top of the provide anchors. And one note here, require anchors, the initial sets, we can even bundle them with the software. I don't know whether we want to do that, but we can. But provide anchors with delegate on demand, know your consumer, which brings us to the process and the ceremony I was talking about with Serdar. Okay, and what's the big picture? Know what it has to trust anyone but themselves. That's it. That's the best you can do. We do it. Okay, any DMS owner is in charge of his own fate. Okay, you can manage your anchors of trust however you like. Okay, the only trust you can give us, and we ask you to give us nicely, is basically to vet the users, right? And for public behavior, the capability is very narrow. Okay, this is the required anchor I was talking about. We can ship the software. And basically, if someone wants to interact with the public network, they can ask us for a token. And our role is maintaining the peace and order, right? So know your customer, know your user. We're going to have to ask for some basic information like name, organization, email, like something like that. And that's it. But others can do it too, and if they're trustworthy enough by owners of DMS, they can do this process. All right, that's it, folks. Code, a couple of PRs, 3 PRs, one in a week. The other 2 has merged in domain. Serdar, please review the code in main. You merge you too. That. I would appreciate if you can do it before next Friday. So if there are any defects, we can find them early. And that's all, folks. Happy hacking. Any final questions before we jump into the daily?
Can you go back to PRs? Let me take it.
Yeah, sure.
Yeah, I wish we can give more time to the require and provide. I still feel like I want to dig more into that.
Okay, read the code, Jude.
I think I also did not fully understand the anchors part, so I will look into it later on.
Okay, all right. You guys read the code, and we can even set up a huddle during office hours if you like to discuss in the vectors.
Sounds good. Thank you.
But please read the code first. The answers are there.
Well, we can also schedule another technical discussion for more.
No, please,
questions.
that was draining. That was a very long one, a lot of information packed, because we had a 1 hour constraint, right? So, okay, it's better to just schedule a huddle for, Q&A, but please read the code first.
Okay. Thank you, Visa.
Thank you, folks. Thank you for listening, and thank you for all these questions. I'm happy.